Ahead on Catalyst, Mark Horstman takes a class action.
Scientists go back to school to help grow a clever country.
Mary Ann loses sleep in the name of science.
I'm about to get behind the wheel after only 4 hours of sleep.
And Ruben samples air from the 60s.
The last time this scuba tank was used, the Beatles were the top band in the world.
G'day, welcome to Catalyst. This week is National Science Week, and there are activities all around Australia designed to bring out your inner scientist. Indeed, that's what this episode of Catalyst is all about. Ordinary people getting involved in the scientific pursuit. Citizen science. Now, what better place to develop a love of science than in the classroom? So Mark Horstman goes back to school to join scientists who are bringing their passion to the citizens of tomorrow.
Back in the day when I was in primary school, this seemed to be what science was all about. A lot of cool stuff with heaps of promise that you weren't allowed to touch.
Work in science involves reading a lot of scales on a lot of instruments.
For many years, the way science was taught stopped school kids at the blackboard.
I don't want to do an experiment right away because it would be a bit difficult to show.
Education may have changed, but how to prevent the interest of students sliding away from science remains a challenge.
If you look at the stats about what high school students are studying, there's evidence of a looming crisis in science education. Since 1992, the proportion of Year 12 students studying physics and chemistry has dropped by around a quarter. Biology, nearly a third.
And a small amount of this into that container.
Now there's a quiet revolution in science education rippling through our classrooms. And I don't mean a building site with politicians in hard hats. It started with a big idea from Australia's former chief scientist, Dr. Jim Peacock.
I wanted to try and get the science of now, not the science of the last couple of centuries, to add interest to the curriculum of science in schools, both primary and secondary.
The program is called Scientists in Schools, and it works a bit like online dating.
They register on a website, same with the teachers. We talk with them and they register, and then I have a little team that tries to match a scientist with a teacher.
This is what the program looks like in real life on the rocky shore at Taroona near Hobart.
I've got some photos here from when we were down here last time. I want you to have a look at these.
This grade 7 class adopted Dr. Louise Emerson as their own scientist more than a year ago.
I wanted to bring the children down on a field trip. My profession is as an ecologist. I love field work. Who can spot an anemone?
There's one there. There's one right down there.
The class maps the life of the rocky shore by running transects and counting quadrants.
I'll go this half, you go that half.
Oh, this is one of those tricky seaweeds that I don't know what they are. If we can inspire these kids about science, if we can get them to think that science is not this big scary thing out there that only crazy people with lab coats do, then I think we've made a lot of progress.
And how would you go about counting these?
For teacher Lynn Murray, it's a chance for her class to learn about scientists as much as science.
I got the children, before they knew about it, to draw a scientist for me, as they thought a scientist would be. And I got white-coated males in a lab. So when I did ask for a scientist, I asked, could I have a female scientist, because I could see the value for the students in breaking down that stereotyping for them.
Just kind of see the whole beach differently.
So sort of makes you take a second look at it.
Yeah. And usually when you think of beach, it's kind of just sand and rocks and water. But when you think of it in a sciencey kind of way, it's kind of like there's more different things like animals and stuff that live there too.
I don't want kids to reach high school, watch the news and feel like they can't do anything. I want these kids to believe that they can make a difference.
Column with...
The next school day, I'm in Carol's grade 4 class, who have also adopted Louise as their scientist in residence.
Today we're going to be doing a session called Cabbage Chemistry.
They're using red cabbage juice as a natural litmus test.
We're going to measure a whole bunch of household substances and we're going to test to see what pH they are. So we're going to test to see whether they're acids, whether they're bases, whether they're neutral.
The shampoo is violet. Purple or violet, and it's an acid. And the last one's a toilet cleaner. It's purple and it's 4 and it's an acid.
You always laugh when you say toilet cleaner. Why's that?
Yeah, it kind of looks funny because toilet cleaner's gone pink.
If you do science in your classroom, all the kids want to write about it. They want to draw the diagrams, they want to ask those questions, and so it helps in every area.
You've created something completely new.
If they see that it's a normal job that anyone can do, if you're passionate about it, and that you don't have to be Albert Einstein, I think we'll get more scientists. We'll get more kids doing science in high school.
Such positive responses from teachers helps explain why the Scientists in Schools program is reaching more than 1/10 of Australian schools and an estimated 340,000 children.
Here we go. You want to try that one on? You've got that one?
Scientists in the program need the support of their employers and to negotiate the activities they want to do with the teachers.
There you go. I've negotiated 6 two-hour sessions a year, which is less than 3 days of my working time to come into this classroom and be part of the program. So that's not a huge commitment in terms of my time.
What do you guys like about these lessons?
Exploding.
Exploding? How about you? Does it make you want to be a teacher?
No. No, I really like coming into the classroom for short bursts of time. But the teachers, I mean, it takes so much energy, and I always walk out of the classroom after these sessions and think, I think all teachers need a pay rise, and aren't they amazing?
You know, you're supposed to work these things out, how much they cost. Well, a year's worth of this for one child is $3 worth. It's not bad.
Now that you know the chitin, the Aboriginal word for chitin is taruna. We're not trying to turn every child into a scientist. That is not the goal. What we want to do is make them find science palatable, make them understand that they can be a scientist if they want to, and just continue to keep them engaged in science.
If you were sitting in a room with the Prime Minister and all the state education ministers right now, what would you tell them?
I'd tell them to come and look with me at one of the classes where the teacher and the scientists are coming together. It's magical. It would be hard not to respond to that in a positive way.
Still to come, air retrieved from the 60s.
A very good vintage.
Sleep deprivation can be a terrible thing. Thinking clearly when you're tired is difficult, and driving or operating machinery is very dangerous. Now, extreme sleep deprivation is actually quite rare. A more common problem is partial sleep loss, known as sleep restriction. Well, to investigate that, Dr. Mary Ann DeMacy and I visited the Woolcock Institute for a really bad night's sleep.
We all love a good night's sleep, and let's face it, not enough makes us grumpy and drowsy. Now, sleep researchers are showing that restricted or interrupted sleep may be more harmful than you think.
What we know about sleep is if you don't get it, you start to suffer.
There's a relationship between disrupted sleep and the risk of obesity, the risk of diabetes, and the risk of heart attack.
These researchers are looking at how disrupted or restricted sleep affects metabolism as well as brain function. Graham and I are about to spend a night in a sleep lab to feel the effects for ourselves. First, we're both put through a series of tests to check our baseline reflexes.
As soon as you see the red light, you press the button, and then that'll give you your reaction time in milliseconds.
It's quite stressful.
Oh, God, I am so slow. Then came the test for vigilance.
Just pull the lever when you're ready, and then you'll be off.
All right, see you in an hour and a half.
See ya.
This is a long road to nowhere.
With the baseline testing out of the road, the fun part begins. Getting wired up.
Just like getting your hair done.
Hey, look at that.
Okay, all done, all wired up.
This experiment will investigate our cognitive function after each of us experiences a bad night's sleep.
Yeah, well, I think it's my bedtime, right?
Graham will be getting a full 8 hours. But the bad news is he'll be disrupted every time he gets into a deep sleep.
I'm not going to sleep. It's dark.
While Graham drifts off under the gaze of the night vision cameras, we monitor his progress in the control room.
These black lines here are his brainwave activity, so we look at the patterns in that brainwave activity to see what sort of sleep he's having, whether he's awake or asleep.
People 100 years ago thought it was sort of like your brain just went dead and didn't understand about different stages of sleep. I mean, the understanding of stages of sleep wasn't really refined till the 50s.
Essentially, sleep is divided into rapid eye movement, or REM, which is when we dream, and non-REM, which includes the slow wave sleep.
Well, slow wave sleep by its name is when the brainwave activity starts to slow and you get these waves that are slower than the standard sort of faster frequencies that you see.
So essentially you're going to stay here all night and wait for him to get into that deep sleep and then wake him up?
Yes.
Now I have time to kill. As part of the experiment, I'm being restricted to only 4 hours of sleep. So I have to try and stay awake till 2 a.m. But at least when I do get to bed, my sleep will be uninterrupted. So, unlike Graham, I should get some deep sleep. Finally, it's 2 a.m.
At last. Bed.
As one falls into sleep, one falls into deeper and deeper sleep. And this deep sleep, or slow wave sleep, is thought to be very important for the secretion of a number of very metabolically active hormones. And so we therefore believe that sleep is intimately related to metabolic health through these hormones.
This could have a serious impact on people with sleep disorders such as sleep apnea sufferers, who have breathing difficulties during the night.
I was waking up 48 times per hour. These are awakenings that you're not aware of. They're not conscious awakenings. It's just you're falling out of deep sleep, so you're not getting any quality sleep.
Many patients with sleep apnea get very broken down slow wave sleep. They'll still have a bit of it, but it's chopped up when they snore and stop breathing and wake up. So we're looking at the importance of that in those sort of patients.
Getting a bad night's sleep also affected Michael's metabolism.
During sleep, certain metabolically active hormones are secreted. So, for example, growth hormone is secreted during slow wave sleep, this deep sleep. And if you don't have slow wave sleep, then you don't get this growth hormone being secreted.
This could increase the risk of diabetes and obesity, and it also affects lipid processing. Once Michael's sleep apnea was successfully treated, he saw a remarkable improvement in his metabolism.
My body processed the lipids 25% better.
Lights on, how are you? Good morning. How are you doing?
That was awful.
We'll get you unplugged and then we'll do some driving tests.
I definitely want more hours sleep.
That was perhaps the worst night's sleep I've ever had, I think.
Now, in our sleep stupor, it's time to get tested again.
I can barely focus on the numbers.
This is not going to be good.
Let's see how we go with this.
It's so
bad. Oh my God.
Almost hit the truck.
An hour and a half later... Finished!
That was awful. I'm never doing that again.
Now for the results.
You go into this stage of sleep, which is slow wave sleep. You can see the brainwave activity is a lot sort of slower.
Yeah. So how does this compare to Graham's?
The moment we saw a hint of slow wave sleep, we'd hit him with sound. And you can see here, these are the sound hits.
So how many times would you hit him with a noise burst?
Lots. Looks like up to 300 times across the night.
300? Wow.
While Graham had twice as much sleep as I did, he had virtually no deep sleep. So how did this affect our ability to think?
Well, this is the most interesting graph, I think. And what this shows us is that for fatigue and your ability to drive straight...
I did worse.
Much, much worse compared to Graham.
Wow.
What this tells us is that for driving ability, the slow wave sleep component is not important.
Surprisingly, slow wave sleep wasn't crucial for Graham to maintain his concentration. But what would have been the effect on his metabolism?
What we predict is that the glucose metabolism, the metabolism that's important for diabetes risk, will be affected by the deepness of sleep.
Until the study is complete, there's one thing we do know. Nothing feels better than a good night's sleep.
How well do you sleep? Well, as part of National Science Week, ABC Science has teamed up with sleep researchers to find out. And we're encouraging you to lie down and be counted in the Big Sleep Survey. For details on that, go to our website. Now, atmospheric research. An important part of this science is collecting air samples from the past to compare to the present. Now, we've heard a lot about the tiny air bubbles trapped in ice cores that provide samples hundreds of thousands of years old. But, as our surfing scientist Ruben Meerman finds out, they're not the only archive of air.
Scuba tanks reveal the world under the waves to scuba divers. But it's what's inside scuba tanks that's revealing something to scientists that might really surprise you.
The air in one old scuba tank has given atmosphere scientists a rare snapshot of our environment's past.
It was in the shed in here.
In 1968, John Allport had his scuba tank filled with air at a dive shop in Spencer Street, Melbourne.
We went down to Mornington, just south of the pier. Only were in the water for about 5 minutes, but it was too dirty and you couldn't see anything, so we decided to get out. I never used them from that day on.
And so the tank sat in John's shed for the next 40 years. In 1978, Dr. Paul Fraser started the CSIRO Air Archive. The air monitoring station at Cape Grim in northwest Tasmania is one of the best places in the world to collect air because there is nothing for hundreds of kilometres upwind to contaminate the samples.
Wow, lots of bottles. Lots of bottles. We've been collecting bottles since 1978 from Cape Grim in Tasmania. There's some really old ones over there. Is that the oldest you've got? Yeah, the first tank right up there is from 1978, April, I think, of 1978. I just turned 7. Is it a good vintage of air? A very good vintage. The levels of greenhouse gases in that tank are significantly lower than we see today.
In 2008, John and his wife Marg were watching TV. Catalyst, in fact, when something caught their eye.
This is the oldest specimen. It comes from Cape Grim and it was collected in 1978.
I've got air older than that in the shed.
Why am I not surprised?
Next thing was to go out and get the air bottles out the next day and check them. And yes, they still had air in them. And that's then when we rang CSIRO in Aspendale.
John, in typical John fashion, he said, I've got an older air sample than you have. And I said, that's wonderful, thank you. And he said, would you like to have it?
CSIRO didn't want to just store John's old air, they wanted to study it.
So this is the machine that gives you all your results? It is. It's a mass spectrometer gas chromatograph, or GCMS as they're called. and it measures very, very low levels of greenhouse gases in the archive.
What did you find out when you looked at John's tank?
We got the tank from John and we found new record low levels of greenhouse gases. But this is the lowest value, for example, of sulphur hexafluoride or carbon tetrafluoride that we've ever seen in a contained air sample.
The data has been compared with measurements from air trapped in ice core samples from the Antarctic and from air in the archive. Some gases, like the ozone-destroying CFCs once used in refrigerators, can be seen increasing before they were banned in the late 1980s. Other gases, like the HFCs we now use in refrigerators, aren't seen in John's sample at all because in 1968 they weren't being used or we hadn't invented them yet. And that confirmed John's air truly was from the 60s. The air is safe in the CSIRO archive, but Paul has returned the tanks to John.
How did it make you feel to know that you've contributed this great air sample?
Quite proud, really, because otherwise you would just let it go. And I hope somewhere somebody can come up with an older one.
So CSIRO are putting out the call. Are there other old scuba tanks full of air floating out there?
You might think years of study are required before you can do real scientific research. But that's not necessarily the case. Truck driver Terry Lane is a passionate naturalist in his spare time, and his work has had a dramatic impact on the home of some very special creatures. Tanya Ha joined Terry on one of his field trips.
I'm a truck driver. I do it because it's probably the only thing I can do. I was always an armchair conservationist until one day I thought, do it.
Although he spends much of his life on the road, Terry Lane lives for his time out here.
This park is very close to home. And now that my children have all grown up and left home, I can do what I want to do, if my wife lets me.
Does she?
That's a harder battle, is to get out the house, actually.
For the past 5 years, Terry has been helping look after Organ Pipes National Park.
And climb into the waders and get into the water.
Back in 1972, this whole area was nothing more than degraded farmlands.
It was a dumping ground. Very few trees. The idea was, let's get rid of the weeds. I quickly learned that conservation is not just planting a tree in the ground.
Nearly every tree you see here has been planted from seeds native to the area. With countless hours from volunteers, the natural habitat is returning. And so is the wildlife.
One of the best ways to check the health of an ecosystem is to immerse yourself in it.
What we're looking for are macroinvertebrates. Now, macroinvertebrates are tiny animals without a backbone, and they're the beginning of the food chain. Just be careful because it's getting quite deep. And you can, that's the way. But so this is the best workout. You don't need to come to the gym, just go down to the creek.
How's that look?
Muddy. But that's good. Oh, wow, there's a lot of caddisfly. I can see a lot of caddisfly.
But they look like sticks with a little tongue on them.
Very sensitive to water quality. Look at the shrimp. Look at the shrimp, the size of the shrimp.
Gee.
There's a stonefly. Look at that one, stonefly.
Oh.
This is critical. It's critical for fish, for frogs, the whole food chain. This is a really healthy waterway. You can just tell. First time I heard the growling grass frog, I was so nervous trying to record it. I had to do it about 3 or 4 times because I was so excited that I'd found an endangered species. It's very important to find out what's happening. Frogs are disappearing all over the world, and where we are here, it's no different.
Often as late as 4 in the morning after a 12-hour shift, Terry will head down to the park to count frogs.
You don't see frogs, you hear them. I've got my digital recorder. I would note down the temperature, the weather conditions, and that data then I put down into a field sheet that I've developed.
Every piece of information Terry collects is entered into a database and sent to Melbourne Water. It forms part of a monitoring program on the local environment.
It's something that's easy enough for the lay person to do. It's not difficult. It's collecting data and then sending it off to people that are, well, a lot smarter than me, and they make sense of it all. And that is a feeling in itself that you're contributing, and that's a wonderful feeling.
Next time on Catalyst, the Oscars of Australian Science, the Eureka Prizes, and the winner of the People's Choice Award. Well, that's it for now. I'm Graham Phillips. Thanks for watching.